Hey YouTube, welcome to another video. In this episode, I will be sharing a new router and stick design based on the new capabilities that has been added to Omada. I am really very excited to have this capability, and as I have mentioned in the previous video, this is a major game changer. And I'm not using the word game changer lightly, as I truly believe this new capability truly makes Omada a heavy contender in this space. To put a little perspective on this, let me share a few background and my history with Omada. I have two versions of NewGen LAN. Both of them are router and stick setup. The first version of NewGen LAN was mostly switch centric, but it was the first video that introduces the idea of granular ACL, which is an IP port based ACL. The second revision of NewGen LAN came when stateful LAN to LAN ACL and MDNS were added to Omada. It lessened the dependency on switch-based ACL and made stateful gateway ACL very newcomer friendly. Both the first gen and the second gen LAN designs are unique compared to other Omada LAN designs you can see in YouTube videos and guides at the time, because both use granular ACL and have also introduced the idea of pseudo one-way ACLs via the switch. Stateful gateway LAN to LAN ACL is good, but it was lacking granularity. The next one I have shared is the next gen LAN. This is another router on stick design, and it is very switch centric design and very tricky to implement. In that design, it ensures all new VLANs that are created are isolated from all other networks. This is also another first of this design that has been shared in YouTube. And finally, the latest one I have shared is the advanced gen LAN design. Just like the other two major LAN designs, this is the first of its implementation shared in YouTube and in any other written guides on the net at the time. And now, the feature that I have always wanted for the gateway is finally added, and as I have mentioned in my previous unboxing video, this is a game changer. And I'm calling this version of LAN design as IsoGen. It has a similar functionality. It's not the same as my next gen LAN design, but this is so much easier and it is so much faster to implement. It also made one of the switch port feature so much more useful, which is port isolation. Anyway, this has been a very long intro, so without further ado, let me just start what IsoGen LAN design is. This is IsoGen LAN 2026 edition. If you have been watching my video for quite some time, you will be very familiar with this design, but there are several new implementations in this design. That's why I call it IsoGen. The quick summary of the design differences versus the previous designs that I had before, like New Gen LAN, Next Gen LAN, and Advanced Gen LAN, are the built-in network isolation. None of the previous designs have used that. There will be a private LAN as well, and there will also be a bridge VLAN. These are the legends in here. I'm sorry if the colors are very similar, but they are as unique as I can make it to be. In this video, I will be using a hardware controller. This can be an OC300, OC220, or an OC200, as long as you're using the latest firmware. This is a router on stick configuration. So all the routing is done via the gateway and the router. In here, this is just a visual representation of a switch, but I have multiple switches in here. For this design, I will only have one access point. So let me just go to this table in here, this matrix. Note that for the names of the VLAN, these are just names. What's important is their use cases. Each VLAN in this configuration is unique, meaning they serve a certain function, they serve a certain use case. Let me just go through each and every one of them. For the admin VLAN, it will have internet access. It will be able to access its peers and neighbors. It will have access to the management VLAN, which is VLAN 1 or 192.168.0. It will have access to other VLANs. That's why there is an inter-VLAN column in here. It will have access to bridge VLAN. And it can do granular access, but it doesn't have access to the perimeter. For the home VLAN, we'll have access to the internet. It will have access to its peers and neighbors, meaning all devices within the same VLAN will be able to communicate with each other, but it will not have access to the management VLAN, so it will not be able to access the switch, the gateway, and the controllers. However, it will have access to other VLANs, namely the DMZ. So that's why the inter VLAN says yes. It will not be able to access the bridge VLAN, which is the MDU. It will have access to granular access, meaning IP port based ACL, so it will have granular access and it will not have perimeter access. Guess is wireless only. Other than the internet access, everything else is a no. So for the camera VLAN, the use case is that it will not have access to the internet, but it will have access to its peers and neighbors. It will have no access to the management VLAN. It will have access to other VLANs, namely the DMZ, and it will not have access to the bridge VLAN. It will not have access to granular access, and it will not have access to the perimeter VLAN. For the IoT, it will have internet access. It will be able to see its peers and neighbors, but it will not be able to access the management VLAN. It will have access to inter VLAN, namely the DMZ. It will have no access to bridge, no granular access, and no perimeter access. So the DMZ, this is pretty much new for this particular design because of the network isolation implementation in TPLINK. DMZ is the VLAN that is not isolated. This one will have internet access. It will have access to peers and neighbors. It will not be able to access the management VLAN. It will not be able to access other VLANs other than its own. It will not have access to bridge. It will not have granular access and no perimeter access. The isolated VLAN is very much like a guest Wi-Fi. Guest is just Wi-Fi only, and isolated VLAN is wired only. However, the only difference is that it will have access to other VLANs, namely DMZ. Internet access, yes, it will have. No access to peers and neighbors. Peers and neighbors meaning other wired connections. It will not have management access. It will not have access to bridge, no granular access, and no perimeter access. So MDU, this is another new for this particular design. This is a multi-dwelling unit. This is a bridge VLAN design, which I covered in a separate video in the past, and I figured it will be interesting to include it as a part of an overall network design for your home. So it will have internet access. It will have access to its peers and neighbors within same VLAN ID. It will not have access to management VLAN. It will have other VLAN access, mainly the DMZ, and it will have access to the bridge. It will not have granular access, and it will not have perimeter access. So the KIP, as you can see here, it has access to everything. So this will be your super duper secret network where all other VLANs cannot access, but you can access anything and everything. This will be your sanctuary. It's an isolated network within an isolated network within an isolated network. So that's pretty much the design. So now let me jump to the Omada console. For this configuration, the absolute must-have device is the ER685 version 2.0 hardware. For the switch, you need to have a managed switch that supports port isolation. And for the access point, I only need it for the guest Wi-Fi. And going back to the gateway, if you have a newer or better gateway, chances are it supports network isolations. Make sure you have the latest updates, and as well as you have the latest Omada SDN version 6.0. So let me just go to the configuration. So network config, and then LAN. These are all the networks that I have covered in the LAN diagram. The only thing that will somehow look a little bit different will be the MDU, because bridge VLAN means one IP network with multiple VLAN IDs, but all the rest of the other networks will have single VLAN ID. If I go back to my design, you can see here VLAN 1, 10, 11, 12, 13, 14, 15, and then 16. The keep VLAN is not yet being shown. I will cover that later, but I just want to say that my device, my machine, this PC that I'm using for recording is in the keep VLAN. I have several VLANs in here that are tagged isolated, and then there are a couple of them that are just regular network, or in TP-Link's parlance, it's interconnected network. To be able to see this in a much easier setting, go to isolation settings, and you will see all your isolated network in here. You can see here the isolated network will only access the internet and cannot communicate with any other networks. In here, interconnected networks can communicate with each other, but actually that only is true for the DMZ, because the guest Wi-Fi, we will use the Wi-Fi isolation feature using the access points guest feature. So let me just quickly get to it. The wireless configuration, network config, and then wireless LAN. I only have two SSIDs in here, but this should be enough to demonstrate the whole SID configuration for all other networks and future networks. One thing to notice here is the V1 in here. This is the admin VLAN, and you can see there's no VLAN assignment in here. And then the guest Wi-Fi, you will see it has VLAN assignment in here, VLAN 11, and the guest network is checked. So if I click edit, and you will see that this configuration here is very simple. You can see here, if you would like to assign a different VLAN, let's say this is a home Wi-Fi, what you can do is click advanced settings, and then instead of the VLAN default, I click custom, you will be able to select all the rest of the networks except the admin VLAN. So if you would like it to be home, that's it, and then click apply, and then you should be okay. I'm gonna click cancel. So I'm gonna show you that VLAN configuration here in the guest Wi-Fi, because I would like to cover another point here in the guest Wi-Fi. So I click edit. In here, the guest Wi-Fi, the most important thing is to click the guest network, and you will see here this I in here. It will tell you that all clients in the wireless network will not be able to communicate with each other. This may restrain the functions of AirPlay, Chromecast, Sonos devices, screen mirroring, and wireless printers. So guest network does that. And you will see on the add VLAN, you can see here it's the guest network, which is VLAN 11. If you have a different VLAN, all you have to do is click here and then select the proper VLAN for your guest VLAN. But this one is purely wireless for the guest VLAN, so that's pretty much it. So click cancel. That covers the network configuration, the VLAN configurations, as well as the SSID configuration. Let me just go to the clients in here to give you an idea of how the clients are configured. In here, you will see I have a lot of clients. I have the Omada controller, which is the 192.168.0.100, this one. And then I have a bunch of Raspberry Pis and a Samsung laptop. And they will be connected to the respective VLANs. You can see here VLAN 1, and then VLAN 10, home, VLAN 11. This is the guest Wi-Fi, and it connects to the access point. And I have the camera VLAN, the IoT VLAN, DMSA VLAN. I have two of them in the DMSA for testing purposes. I have the isolated VLANs. I have two machines in here for demonstrating the port isolation, and I have the MDU in here. In the MDU, you will see while I do have VLAN 16 and 17, they are in the same IP network. One thing that you will not see here is my media PC, which is in the keep VLAN. The idea of the keep VLAN is to be able to hide your PC, your network, but still having full access to your VLAN. Let me just show my IP network here. So this is my media PC. This is the device that I'm using for recording, and you can see I'm using a different IP network scheme that is totally different or non-existent in this particular network. I'm using 192.168.2.100 with /24 subnet mask, and you can see that it's nowhere to be seen in this IP network. So these are all of the clients. You can see I only have one page in here showing 1 to 12 of 12 records, and that's how it is. Now I'm going to move on to the ACL. So network config and ACL. So one thing I would like to share and focus on this ACL screen is that since this is a pure gateway centric design, I don't have any other ACLs on the switch nor in the EAP on the access point. So if I go back to the ACL, you will also see that for the very first time, I'm able to do IP port granularity with this line. In the past iterations of the SDN and the firmware, you need to have a switch ACL to be able to allow port granularity. But this is amazing. Everything here on my design in here is covered with just 4 ACLs. And you can have less ACL. For example, if you don't need granularity, then you can remove this one. And if you don't want to deny any network access to the internet, you can remove this one. This network isolation configuration is really powerful, and I'm able to configure this network with just 4 ACLs. In the past, I will require at least 9 or 10 or even 12 ACLs to be able to configure all of these configurations on my network. Let me just go through this very quickly. A lot of these ACLs are LAN to LAN, except for this one, camera to net, which is the LAN to WAN. And you can see also the policy, whether it's a permit. All of them are permit except for one, which is deny. And in here, I use TCP specifically for the granular ACL. And this is how my source and destination networks is configured. You can see here, for example, for permit admin VLAN to everything, this will be a LAN to LAN that allows management VLAN to access all LAN IP networks. For the permit also DMSA, it permits any IP network on the LANs to access the DMSA. For the camera, you can see this is the only one that goes LAN to WAN. It only prevents the camera VLAN to access the wide area network. For the granular access, you can see this is only specific to the home VLAN, which access the VLAN 13, which is our IoT network. I would like to demonstrate it using SSH to the IoT VLAN and not the other way around. Now I'm going to move on to the demonstration to demonstrate this particular configuration. To shorten the video, I decided to pre-record my demonstration as well as the configuration section of this episode. For this reason, the video will be sped up. Now let me start doing the voiceover for the demonstration. On this screen, you will see that I have 12 clients, and you will see all the VLAN on each client. You can see I have VLAN 1, VLAN 10, 11, 12, 13, 14, 15, 16, and 17. On this screen, you will see that I have a VNC client, and I'm connecting to all the clients, even the wireless one. So I did hack the wireless connectivity, so that's the reason why I can connect to the Wi-Fi client. Normally, you should not be able to do that, but in order for me to demonstrate it, I have to do that extra ACL. On this screen, I'm showing that the media PC, the PC that I'm using for recording, is in a VLAN. In fact, I'm using a 192.168.2.100, which is a different IP network from all the VLANs that I have in here. So right now, I'm doing a quick ping of all the VLANs and all the clients. So in the keep VLAN, you can see that I can access all the clients without any issues. Everything is deploying. So now what I'm doing is I'm transferring the cable to the admin VLAN from the keep VLAN. Okay. That's what I'm doing here. I'm transferring the cable to the admin port. There you go, and now it's deploying. And my IP will be in a different VLAN now. So I'm now in the admin VLAN, and if I refresh the screen, as you can see, I will have 13 clients instead of 12 clients, and I'm getting an IP address of 192.168.0.105. So in this screen, I'm now testing the home VLAN. So this is showing the use case for the home VLAN. It shows that I cannot ping the management VLAN, I cannot ping the Omada console, and you will see that the rest will be the same except for the DMZ VLAN. In here, I'm showing that my D-Link has VLAN 10, VLAN 12, 13, 14, 15, 16, and 17, corresponding to port 2, 3, 4, 5, 6, and 7. And you can see on the mini screen that I'm transferring my admin PC to port 2 to the D-Link switch so that it will be in the home VLAN. This will allow me to get an IP address on the home VLAN, as you can see there, and you will see that I will be able to ping its peers and neighbors. So I'm demonstrating here the peers and neighbors capability. So moving forward with the screen, you can see that I'm trying to ping all the rest, but in here you can see that all the other VLANs are not reachable except for the DMC VLAN. The DMC VLAN is accessible by all other VLANs except the guest network. So in here, I'm still trying to demonstrate that I cannot access all the rest of the other VLANs. Now I'm going to bring back my admin PC to the admin VLAN so that I will be able to access all the rest of the machines. So you can see here, if you're looking at the device camera, I'm transferring my cable from D-Link back to the one of the ports in my Omada switch. And you can see that it's applying again. There you go. And if I check my IP address, you will see that I'm back to my admin VLAN, which is 192.168.0. So the next will be the guest Wi-Fi. You can see that I have a wireless signal, wireless icon on the upper right of this particular screen, and it cannot ping anything else, including the DMZ. The DMZ VLAN is accessible by all the other VLANs except the guest network. And you can see that I ping all the rest of the networks and I cannot see it. So this one, 192.168.12, is a camera VLAN. The camera VLAN doesn't have internet access, but it has access to its peers and neighbors as well as to the DMZ VLAN. I also demonstrated there that I can reach the internet. I ping google.com, I cannot reach it. And again, I'm just showing the D-Link configuration here. If you're looking at the mini screen or the device cam, you can see that I transferred it to the port that corresponds to the VLAN 12. And you can see that the ping for google.com has failed because my media PC is now in VLAN 12. tried it again to showcase that it really cannot reach it, and I'm checking my IP. I should get an IP on VLAN 12 for the camera VLAN, and you can see that I have 192.168.12.101. In here, I'm going to demonstrate pinging the peers and neighbors, which is my media PC. There you go, the 101, I can reach it. So now I'm bringing back my media PC back again to the admin VLAN so that I will be able to continue to demonstrate all the other clients. So you can see once I'm back to the admin VLAN, I can reach google.com without any issues. And if I check my IP again, I should be back to the 192.168.0.105 because I'm now back in the admin VLAN. So I continue to do testing for the rest of the other VLANs with the camera VLAN. Camera VLAN has access to the DMC, but it doesn't have access to anything else other than itself and the DMC VLAN. Go. Now I'm testing the IoT VLAN. Just the same, I cannot reach the admin or the home VLAN. And you can see I cannot do SSH to the home, but the home can do SSH to the IoT because home has granular access. Go. And I check my IP address. You can see the IP addresses for both. There you go. And I'm checking all the rest of the other VLANs. I shouldn't have any access. Now I'm trying to move my media PC to the same VLAN as the IoT so that I will be able to test and demonstrate the peers and neighbors access. And checking my IP 13.101. There you go. I can reach it without any issue. I can also demonstrate that I have access to the DMC. There you go. I'm moving on to the DMC. As you can see, I'm testing the DMC here. I'm moving back my media PC back to the admin VLAN. There you go, I'm back to the admin VLAN. In my DMC, I'm showing that I'm trying to ping everything else. The only thing that I can reach here is another machine in the DMC VLAN. And this one now is the isolated VLAN. The isolated VLAN, just the same, will have access to the DMZ, but it will not be able to ping another machine which is in the same switch and isolated port. So this one is a 15.100. I'm going to ping 15.101, which is another device that is using port isolation and I cannot reach it. So this is that machine, 15.101, and 15.101 cannot ping 15.100. Same thing, 15.100 cannot ping 15.101. Okay, so now I'm moving on to VLAN 16. This is an MDU. I have two VLANs in the MDU, VLAN 16 and 17, but it's using one IP network, which is the .16. Okay, so I'm showing that I cannot access anything else except the DMCA VLAN. There you go. And I went back to another machine in the MDU, and I'm showing the configuration again in here for the D-Link. And you can see in here that I'm transferring my cable. If you're looking at the device cam, I'm transferring my cable to one of the port there, which should be VLAN 16, and I would be able to ping, my media PC will be able to ping one machine which should be in the same VLAN ID, like this one, 16.102. They belong to VLAN 16, but I'm using 192.168.16.100 IP. So, and then if I switch back to another port 8 of the D-Link, which is in VLAN 17, you can see I can ping the .101 IP address that is on that same bridge VLAN basically. So even if I'm using the same IP, it depends on the PVID of the port, which VLAN it belongs. So it's not the IP network that controls it. Okay. So now I'm showing that I can access the internet as well, except for camera VLAN. So that's why I'm doing a speed up access here of the internet access. For the Pi zeros, it doesn't work with the browser, so I have to use pinging to demonstrate that it has access to the internet. Okay. So I believe this will be the last one in the MDU. Oh. And that's pretty much it actually for the demonstration. The next one I'm going to show is how to create VLANs, wireless LANs, and IP port group for the ACL. Go to network config and then LAN and then click add. The first one I'm going to show is how to create the OG VLAN, the traditional interconnected network. Make sure to select the proper information in here. VLAN type is single, enter the VLAN ID, click next and click skip and then click apply. So that will be for the traditional OG VLAN. And I'm going to show that it doesn't have any isolated tag in here. If you go to the isolation configuration, you will see that it's on the interconnected network. Next one I'm going to show is how to create an isolated network. Just the same, make sure that the VLAN information and IP address are entered, and under advanced settings, make sure to turn on isolate network, click next and click skip and then click apply. So this is a purely gateway configuration, not switch based, so everything is on the gateway. I'm showing that it shows that it has isolated settings, and under isolation configuration settings you will see those information as well. So the next one I'm going to show is how to create a bridge configuration. The most important thing here is under VLAN type, make sure to select multiple, enter more than one VLAN ID and enter the proper IP, and under advanced settings make sure to turn on the isolate network, click next and then click skip and then click apply. So very similar steps. So on the screen I'm showing where to find it, that it has isolated network tag, and under isolation settings you will see those information as well. So this one, the next one is port isolation. So this is a switch based configuration, so this is an optional step, but make sure to select and turn on isolate network. In this particular one, in this particular step, you don't have to click skip. Make sure to turn on port isolation and select the necessary ports. So this is Omada based. If using a different switch, you have to do this configuration on the switch itself. Click apply and you should be okay as well with port isolation, at least as far as Omada is concerned. And you will see those information as well on the isolation configuration settings. And I'm showing here that you can drag and drop, as well as using the plus and minus sign or tag on those particular groups to add them to the proper category. Next one I'm going to show is to check the port isolation settings. Go to devices, click the necessary switch, click manage device and then go to ports. Then you will find those port configuration and port isolation settings on the switch itself. There you go. Next one I'm going to create is wireless LAN. So enter necessary SSID. This one is the native VLAN, so you don't have to really enter much information in here. Just click apply and it should be done. The next one I'm going to show is how to put some VLAN ID so that the necessary clients will be on the respective VLAN. So click advanced settings, and on the VLAN select custom, and on the drop down select the necessary VLAN and click apply, and it should list down on the SSID list. Next one I'm showing is how to create a guest Wi-Fi or guest VLAN on your access point. Important thing here is on the guest network checkbox that it's checked, and then you select the necessary VLAN for that particular guest Wi-Fi and it should be okay just the same. Next one is I'm going to show is how to create IP port group for your ACL. So this one, click network config and then groups, And then I'm going to edit the existing one to show you how it's done, but basically you enter the same thing and click apply and you should be okay. I'm showing here the EAP ACL that I use for the guest Wi-Fi so that I can access the guest Wi-Fi for demonstration purposes. This is an optional one. I have to have this to demonstrate the Wi-Fi access for the Wi-Fi client. If you turn it off just like that, I'm showing that I lose access to the guest Wi-Fi client, like this one. And I cannot ping it. Earlier in the demonstration, I was able to ping 192.168.11.100, but once it's turned off, you cannot. And now I turn it off for normal use. And finally, for the Cape VLAN, the only requirement to have is to have another gateway. Any other gateway, it can be an Omada gateway or it can be a different gateway from another brand, manufacturer. It just needs to support NAT. The one thing to make sure for that Cape to work properly is to ensure that the wide area network port of it is connected to the VLAN 1 or to the management VLAN. So let me switch to the device camera in full so that I can show you how it will be done. So for this video, if you are sharp-eyed, you will notice that my media PC was originally connected to this device. So this is another Omada device. This is an ER7406 and I have the ER7406 wide area network. This part connected to the management VLAN of the ER605. But I can also use this device, you can see here, which is an old TPLINK device connected to the management VLAN as well in here, and I can turn it on. Currently right now it's turned off, so I'm going to boot it up. So it might take a while to boot it up. So this is an old TPLINK TLWR841N. So it's putting up, and it has the wide area network port connected to one of the port of the EAP access point in here, and it's getting the IP address to the one port. It should have an IP address of the management VLAN, and what I'm going to do is I'm going to transfer my media PC in here. So this will be another KEEP, and this will have a different IP network than the one in here. This one, the IP network is 192.168.2. I forgot about this one, so I can check later on once it's booted up. I think this is booted up already. Let me switch back to the desktop. So now I'm in the desktop and I'm going to do a ping google.com/t, and I'll open the network configuration as well in here. So let's check my IP address. I am currently in the management VLAN 192.168.0.105. There you go. So if you're looking at the mini screen at the device cam, currently this is where my media PC is. So I disconnected it. I'm putting it at one of the LAN ports in here, and we should observe that what's happening on the desktop. There you go. And you can see that there is a reply, and I'm going to put it down and I'll check my IP address. Let me just go back here. And the IP address of this particular device is 192.168.99.100, and I have the IP address in here for the gateway. There you go. As you can see, I can access it. So that's how the Cape VLAN is. That's why you can use any IP on this one, so long as it's connected to the management VLAN. It should be okay, this one. Okay, so let me turn off this one. So I turn off the device. This should cut off my Cape, and you can see general failure error. I'm going to remove my media PC in here. There. And that's pretty much it actually for this video. I think that's pretty much it for this video. I have demonstrated everything for this particular configuration. If you're able to manage to stay here on the video after this point, I thank you very much for watching the video. If you're interested with this type of video, I encourage you to please like and subscribe and post a comment if you have any questions or clarifications, or if you're confused with anything at all, or if you would like to share something, like teach me something about configuration, please do post that as well in the comments, and I would appreciate that. If you already subscribed to my channel, thank you very much for subscribing to my channel. I'll see you on my next video. Thank you very much, and see you on the next one.